Hey, what's up guys, welcome back to Techno Terrestrian. So in today's video of our Explain series, we are going to explain you that how the liquid cooling system in our phones work. Sounds interesting, right? So watch this video till the end and let's get started. Liquid cooling is the reduction of heat in electronic and mechanical devices through exploiting the properties of liquids. Liquid cooling is a firmly established cooling method in many current technologies. Automobiles, mainframes, and the systems of computer enthusiasts have used water cooling for many years. The methods and coolants can differ between and within these categories. In computer cooling, the most common form of liquid cooling involves a closed system of tubes that carries the liquid from one component involved in cooling to the another. These systems are generally referred to as loops. There are some parts common to all liquid cooling loops: pumps, tubing, water blocks, and radiators. The pump pushes the liquid through a loop and must be primed in order to start circulating the liquid. Pumps burn out when spinning empty as they too rarely in the fluid they circulate for cooling. The tubing is most commonly flexible plastic, often clear but sometimes colored and even UV reactive. Some users have used hard plastic or copper pipe with bent fittings or formed soft copper piping. After the pump, the tubing typically carries the liquid to the radiator where it is cooled for the pump's heat load. Then the liquid moves on the components that need cooling. The liquid is run through water blocks. A water block is similar in function to a heat sink, but the cooled surface area is enclosed within the block. Thermal contact with components is enhanced by thermal compound. Due to the liquid thermal capacity, about 30 times of that of air, the surface area inside is much smaller than today's typically large high-end air cooling heat sinks. Water blocks exist for many computer components besides the CPU and the GPU. There are blocks for motherboards, north bridge, south bridge, chips, and power uptake circuitry such as MOSFETs, RAM, and hard drives. The liquid used in cooling may be de-ionized water or an electrically non-conductive and non-capacitive engineered fluid, of which there are a number of patent formulations. You can't use tap water as the ions dissolved in it are likely to corrode the water blocks. For the same reason, it's inadvisable to mix metals in a cooling loop. You also have to consider algae and bacteria growth that could clog a system, so some biocidal agents should be included. A coil of silver may be used for a biocidal, although it has to be very pure for corrosion prevention. Often enthusiasts choose de-ionized water because of its performance, ready availability, and low cost. There are other optional paths as well. A loop may use a reservoir, that is a tank of liquid, or a 3-way adapted T-line with a fill port. It may have water blocks for hard drives and RAM as well. The liquid may also be actively cooled by thermoelectric or phase change based water chillers in extreme cases. In these extremes, there are additional considerations beyond leaks, like the possibilities of condensation or the freezing of liquid. Liquid cooling supports greater running speeds and quieter running. Among enthusiasts, there is a certain pride in the appearance and prestige of one's cooling solution as well. Liquid cooling used to be the near exclusive domain of the computer enthusiasts and overclockers. Because current CPUs and GPUs run at high speeds, they produce more heat than ever. Pre-packaged closed liquid cooling systems with some high-end CPUs and GPUs. This can be a comfort to those who still are wary of the idea of constructing their own cooling loops. Liquid cooling is becoming more mainstream for personal computing. The densities of data center systems have driven this sector, which is more concerned with stability, to look at its benefits. In this sector, the most common method of liquid cooling is liquid immersion cooling. That is, cooling by submersion in an electrically non-conductive and non-capacitive liquid that is thermally conductive. Some solutions boast as much as 99% savings in cooling related electrical costs for a green data center. I hope you all enjoyed this video. If you like this video and this video was useful to you, Give this video a thumbs up, share this video to your friends, and also don't forget to subscribe TECHNO to get more awesome tech and gaming updates. And also guys, if you have some ideas, suggestions, requisitions or anything, mention that in the comment section below. We'll surely check that out. And I'll see you soon in the next one.